Hi, this is Mr. Shumway. A video clip about series and parallel circuits. So electrical circuits with resistors, voltages, currents. So let's say we have a 12 ohm resistor and a 6 ohm resistor connected in parallel to a battery, and the current in the 12 ohm resistor is found to be 2 amps. Find the potential difference across the battery. Parallel is the key word here. So if I draw a picture of a parallel circuit, the lights in your house are often wired parallel if you have more than one light come on at a time with a switch. So we have a source here, and then we have a wire, and then we have a resistor, and then we have another resistor. So there are two paths through which the current can flow. So those are connected right there. That's often how they show that two wires are connected, is they put a dot. It reminds people of a solder blob. Okay, so one of these resistors is 12 ohms and one is 6 ohms. We don't think it matters right now. 12 ohms, 6 ohms. Okay, so in the 12 ohm resistor we have 2 amps flowing. So we know that going down through this resistor we have 2 amps. Well, we said that the voltage is equal to current times the resistance, and we have both of those now. We have the 12 ohms, so we have 2 amps times 12 ohms. That equals 24 volts. So that battery must be 24 volts. Well, parallel, the way they're hooked up, it's 24 volts here also. Between this plus and this minus is also 24 volts. Well, if I have 24 volts across a 6 ohm resistor, let's see how much current would flow. Well, voltage equals the current times the resistance, and we know that the voltage, let's go ahead and solve that thing for current. Let's divide in both sides by R. So the current equals the voltage divided by the resistance. The voltage is 24, the resistance is 6, so there are 4 amps flowing down through this path. So I have 2 amps flowing there and 4 amps through that circuit, and then they connect back up. They continue, so flowing into the battery would be both of those, so it'd be 6 amps right there. Coming out of the battery would be 6 amps. Then it splits, and 2 amps go down through the 12 ohm resistor, 4 amps go down through the 6 ohm resistor. So there's 2 paths that the electrons can flow through, and so it's easier than either the 6 ohm or the 12 ohm. If I only had the 12 ohm, I would have 2 amps. If I only had the 6 ohm, I would have 4 amps. But having both of them gives us 6. So let's see what the current flowing through that battery tells us about those parallel resistors. If we were to try to combine both of those resistors into one equivalent resistor to see what effect that circuit, the whole circuit, has on that battery. We could analyze what it would look like. We'll say, well, we know that the voltage is equal to the current times the resistance. We know the current, but we don't know the resistance. We know the voltage, so let's find the resistance. So we divide by the current. The resistance equals the voltage divided by the current. The voltage was 24 volts. The current was 6 amps. So the resistance is 4 ohms. So if I connect a 12 ohm resistor in parallel with a 6 ohm, it acts like a single 4 ohm resistor. That makes sense. There's less resistance because there are two paths, two places for the current to flow. So mathematically, we could have found that 4 ohms this way. The 12 ohm resistor, if I add it 1 over 12, and the 6 ohm resistor, if I add it 1 over 6, that I'm going to make common denominators, so it'll be 1/12 plus 2/12. That is 3/12. And then I flip that over, and so it will be 12 over 3, which is 4. So resistors in parallel add as reciprocals. Series is a little different. Let's say we have a 16 ohm resistor and a 12 ohm resistor connected in series with a battery. The potential difference across the battery is 14 volts. Find the potential difference across the 12 ohm resistor. So we'll draw us a battery, and we'll draw a resistor and another resistor. And this one we'll say is 16 ohms, and this one is 12 ohms. We know that the battery is 14 volts. Okay, connected this way, these resistors just add, and I have 16 plus 12 is 28. So my voltage is equal to my current times my resistance. I know the resistance is 28 ohms. I know the voltage, but I don't know the current, so I want to try to find the current. So let's say we have some unknown current flowing that way. So to solve for current, we would divide by resistance. Current equals voltage divided by resistance. So in this case, that would be the voltage of 14 and the 28 ohms. So that gives us 0.5 amps. So half an amp flows through a circuit that is 28 ohms when I hook up a 14-volt battery. So series, the resistors add, so it's more resistive. It's harder for current to flow through a 16 ohm resistor and a 12 ohm resistor. It has to go through both of those. And whatever current I had coming out of the battery at the top is also the same at the bottom of the circuit, half a volt. It's one loop, so the current is the same throughout that entire loop. The question on that particular one was the potential difference. So that's a voltage drop. Potential difference is a voltage drop over the 12 ohm. So let's go to our 12 ohm. Okay, so if I have, there's also half an amp flowing there. The voltage is equal to the current times the resistance. So the voltage is 1/2 times 12, which is 6. So across here would be 6 volts. Well, let's see, the whole thing is 14 volts. So let's see if I have 8 volts here on the 16 ohm. So the voltage is equal to the current times the resistance, which equals 8 volts. Yes, 8 plus 6 is 14. So part of the voltage drops across the first resistor, part of the voltage drops over the second resistor. So it's kind of like a two-step waterfall.